All right, so this is 1-9, and we're looking at example 3 from the notes. So the example is Bob, a city planner, has 2 pieces of metal wire of equal length. He shapes one into a square to represent a new building, and another into an isosceles triangle to represent a nearby park. The base of the isosceles triangle is 4 centimeters shorter than a side of the square, and each leg is 9 centimeters longer than the... Okay, so we have a lot of information going on here, pretty much. So here's how I think of this problem. I've literally got a piece of wire. Oops. If I can draw with this wire. Oh. Hold on one sec, guys. This pencil just stopped working, so I'm going to have to use my finger for a little while. All right, so we've got a wire here. We've got another piece of wire. We take these 2 pieces of identical wire and bend them into shapes. If you really struggled on this at home, what could you have done? Honestly, what could you have done? Use wire. You could have actually used wire. If you have any wire in the house, anything that's bendable that you can put like a vertex in, a vertex meaning you have a polygon, you can bend it to that, it would have worked. So copper wire, or even something at home that just had some sort of a flex to it. Or honestly, you didn't even have to. You could use rope on the ground. Just lay it out on the ground. Cut 2 pieces, both like 20 centimeters, on the ground, make the shape out of it. Just to visualize what's going on. So in case we have trouble visualizing, let's talk about what the shapes would look like. So one of the wires is bent into a square, and the other is bent into an isosceles triangle. If it's isosceles, traditionally I draw it with the base angles the same. So I'd go, that's all right. I'd say this base angle and this base angle are identical to one another. And as a result, these side lengths, just minimize whatever the line is up. That's all right. So these legs are the same length. The base is going to be its own length. It's not the same as the other legs. So as a result, we know that we're going to have the same sides for those. We're given some piece of information. We're told that the base of the triangle is 4 centimeters shorter than a side of the square. Again, take that one statement and translate it. The base of the triangle is 4 centimeters shorter than a side of the square. What should I then do if that's the case? What should I do?
Make an expression, so x minus 4, and x is the one side of the
So on our diagram, let's do that first. Yeah, I agree. Mark x on the square to define some length. We don't know what it is, but let's say that length was like 10, right? If this was 10, you would take away 4, and this would be 6. The base of the triangle, right? Again, you would have an expression there. So we're thinking about it in terms of x. So this simply becomes x minus 4 right here. The square itself, all the sides are x. We know that already. We're then told that each leg, and we're talking about the isosceles triangle, is 9 centimeters longer than that of the square. Each leg is 9 centimeters longer than that of the square. What can I write for the legs of the triangle then as a result? X plus 9 now. So 9 centimeters longer simply means x plus 9. Now, what's the key for this actual problem you have to recognize? There's one thing you have to recognize now. Labeling the diagram is great, but the question is how long is each wire? So what's the key that we have to recognize? Anybody figure it out? It's in the video, obviously, but if you understood it well, can you explain why this next statement was made? What's the key about this problem that we know? What do we know? Yeah. Yeah, both wires initially were the same length. God bless you. Both wires to start were the exact same length. So right now, those wires make up the perimeter of each shape. Therefore, the perimeter of each shape are the same value. So we've got x, 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 and x on this one. So obviously this is just 4x. And that's equivalent to the sum of the values of the lengths of the legs of the triangle on the left. So we sum those together. X plus 9 and x plus 9 gives us 2 of those. And we've got 2x plus 9s. And then we've got an x minus 4 that we're adding to that. I'm putting parentheses. I don't need the parentheses around the x minus 4, obviously. I'm doing that to show that it's a term or a leg. And then I've got 2 of the other legs. And that equals the 4 sides of the square. When you get x, are you done with this problem? I got x equals 14. Do you agree? Are you done, George?
No.
Why not, George? What's the problem ask?
Because the problem asks what's the length of each wire, not like
Yeah, it is not the length of a side of a square, but the length of the wire. Well, if I know x is 14, how do I figure out the wire length? How do I figure out the wire length? Times 4, because there's 4 parts to that x to make up a square. Theoretically, or just plug it in over here also, right? You all see that? The answer of 14 can be plugged in here. That's 10, 25, 25. No, 23, 23. Okay, again, you can plug them in over there and sum those together. But I agree, absolutely. The easier thing is to multiply by 4. Okay, so 56 is your answer for the length of the wire. 56 is the answer for the length of the wire. All right. The next example, so again, if you only needed help for example 3 and you want to start the homework, you can grab a textbook in the corner and start the homework for sure. The homework is at the bottom of the notes. You'll see it says 1-9 problems 7 through 19 odd. I'm going to go through example 4. Example 4 is the distance rate example. So if you want to listen to that for a little while and you're in the mood to go over a quick review of it. So a truck left New York City at 2 p.m. and it left heading to Queensbury, traveling at 40 kilometers an hour. At 3:15, so that's an hour and 15 minutes later, at 3:15, there's more? Oh, gotcha. At 3:15, a car left Queensbury for New York City, and that was heading at 55 kilometers an hour. The truck and car passed each other exactly 2 hours after the car left Queensbury. How far is it from New York City to Queensbury? So this can seem very confusing because of the overwhelming amount of information that's given. That's the first thing I would notice as a student. So much information is given, what do I actually have to use? The other part is this. We have to recognize that, unfortunately, standardized tests around the world for math seem to ask questions that sometimes aren't realistic. Do you drive in a straight line from New York City to Queensbury? No. You drive in some weird contoured path along some curving road the whole time. So the fact that you're driving at this speed the entire time, I mean, you wouldn't really. But again, this is assuming that it's an average velocity for the entire trip. And what we're really figuring out is not just well, in this case, how far, the distance really, if we consider this to be an average speed. And when you get to junior year, you'll talk about that a lot in physics class, the difference between the two. But for now, we're just making simple assumptions here. The first thing that I think about for a problem like this is it's very important to visualize what's going on. So I've got a car here, and then a car over here. They're both leaving, but one leaves a little bit later than the other. So this is what I would visualize. Ready? Car 1 leaves, starts traveling this way. Car 2 then waits an hour and 15 minutes, then leaves. They meet at some point, and the question is, what is the overall distance? So if I could find the distance for each part or each segment alone, I may be able to figure out the overall distance that the actual car/truck, what do we have here again? Yeah, from each city, what they're going to actually travel together, giving us the distance between New York City and Queensbury. So we start over here with first. You had it in the notes. The answer comes out to be 240. 240. So why don't you listen in? And we'll go through it together. How to go through it. So first, you've got a truck here, leaving New York City at 2 p.m. I have no marker, so excuse my crude penmanship with my finger for now. New York City at 2 p.m. for Queensbury, traveling at 40 kilometers per hour. It's going to cover some distance until 3:15. This is 2 p.m. This is a time. So I should put the units so we know that I'm talking about time right now. Then at 3:15, the car also leaves. The car leaves Queensbury, and that happens at 3:15. They both leave, and eventually they meet. Let's see, when do they meet? Exactly 2 hours later, so they meet at 5:15. We know that the car is traveling faster. It's traveling at 55, so they're actually going to meet closer to where the truck was initially. So this is where they meet at 5:15 p.m. So again, I'll put arrows so you guys can see the arrows. So that's how I would visualize this kind of a problem. Again, the truck leaves at 2 p.m. from New York City. At 3:15, we put a little marker down to think to ourselves, okay, now they both kind of left their trip. The car's traveling faster, so they're going to meet closer to where the truck was at 3:15. They're not going to meet right in the middle because the car was traveling faster, obviously. So our question is to find out each segment length and as a result, sum those segments together. Well, from 2 to 3:15, how much distance has the truck covered? Well, distance equals rate times time. So for that first segment, if we want the distance, we know it's 40 kilometers per hour times, what's the time? What's the time segment between 2 p.m. and 3:15 p.m.? How much time has elapsed? How much time has elapsed between 2 and 3:15? Between 2 and 3:15. We need to know our fractions of time, right? Explain it, Annette, sorry.
How much time passed between the two?
Yeah.
So it's 1 hour and 15 minutes.
Which is, what would you write down? Would I write 1 hour, 15 minutes?
No.
What would I write?
You would write, you'd probably write it over 24. You could do that. Or you could write it over 12. No.
I would definitely write a 1 for the 1 hour, but what would my decimal be is my question. 15 minutes is what fraction of an hour?
Oh, sorry.
That's okay.
So it would be a fraction of 60. So
15 over 60, good. What do you got? 15 over 60 is?
15 over 60 is 1 over 4.
Yes, very good. Okay, so 1.25 hours have elapsed since the truck left New York City until 3:15. So this gives us the length of the segment in the beginning. Again, the length of the segment in the beginning, which is 50 kilometers. So we're done with one part. That's the first distance we've determined. Okay, 50 kilometers. Can you see how you would do the next parts of this problem? What would you do afterward? What would you do afterward? Tristan, you started with the question, so I want to go back to where you began, right? So we found out the distance traveled by this truck in an hour and a quarter by taking the rate times an hour and a quarter. Now we need to know, again, how far is the truck travel, how far is the car travel? So what do we have to do in these parts to find out distances? What do you mean compare them? So again, let me point this out. We found the distance traveled by the truck from the city to the location at 3:15, wherever this is. It's an arbitrary location somewhere, doesn't matter where, because this was an hour and 15 minutes, which is 1.25 hours, and the truck's velocity was 40 kilometers an hour. Now, the car's velocity is 55 kilometers per hour. So how are we going to figure out the other two portions of the trip? Well, how much time elapses between 3:15? So the truck is here at 3:15. It then meets the car at 5:15 here. Again, it said after 2 hours, after the car starts at 3:15, 2 hours later they cross paths. So this is 2 hours of time, but the question is, how do I figure out that distance right there? The truck hasn't changed its speed. It's still going 40 kilometers an hour, but it's no longer traveling for an hour and a quarter, which it did here. Now it's traveling for 2 hours. How would I find the distance if I know that distance is rate times time?
You multiply those two, so 40 times 1.2 times.
Now it's 2 hours. Remember, 3:15 to 5:15.
40 times 2.
So it's just
Yeah.
80 kilometers. Okay? Now, the car left at 3:15 also, and the car is getting to this location at 5:15 also, so still 2 hours have passed. And the speed of the car, though, is 55 kilometers an hour. So how would you find that distance traveled?
Again,
Yeah, again, rate times time. So 55 times 2 gives you 110 kilometers. So there's our three answers we have to sum together. So again, D1 is the truck starting at 2 until 3:15. D2 is the truck from 3:15 until 5:15. D3 is the car at 3:15 leaving until 5:15 when they cross paths at 5:15. So you need to visualize. Ready? This is what you have to think. The truck leaves, then suddenly the car leaves at 3:15, the car travels faster, and they cross paths. That's what the problem tells us. So we need 3 segment lengths, we need to sum them together.